The null hypothesis states that there is no significant difference between the two population means. And then the second one, the alternative hypothesis, states that there is a significant difference between the two population means. As you may have noticed, our t statistic of 0.4159 is less than the critical t value of 2.306. That is why we can also determine whether the mean difference is significant or not using confidence intervals. In this video, we will be performing an independent samples t-test given the summary statistics. The question goes, a researcher is investigating whether there is a significant difference in the average scores of two different teaching methods for a standardized test. The researcher randomly selects two groups of students. Group A is taught using method 1 and Group B is taught using method 2. After the teaching sessions, both groups take the same standardized test and their scores are recorded. We have the following summary statistics for the two groups. Perform an independent samples t-test at a significance level alpha of 0.05 to determine if there is a significant difference in the average scores between the two teaching methods. Assume equal variances for the two groups. We proceed by opening the app. Click the menu over here. Search for independent samples and select the specified calculator. To answer the question, is dataset given? We select no in the drop-down menu since we are given the summary statistics. Next, we will input the given data. For Group A Method 1, we have N1 is equal to 5, X bar 1 or the sample mean equal to 84.4, and the sample standard deviation equal to. And then for Group B Method 2, we have N2 is equal to 5, X bar 2 equal to 82.8, and S2 equal to. So for the significance level alpha, this is given in the problem as 5% or 0.05. And since we are asked to determine if there is a significant difference in the average scores between the two teaching methods, this gives us a hint that we are to conduct a two-tailed test since there is no indication that sample 1 is greater than sample 2 or sample 2 is greater than sample 1. So in that case, this is a two-tailed test. And we are also told to assume equal variances. Now that we have finished filling the required values, we proceed by clicking the button and watching an ad to unlock the solution. We now proceed with performing the independent samples t-test. Step 1, we formulate the hypothesis as shown below. So we have, since we are conducting a two-tailed test, it follows that the alternative hypothesis will use the symbol is not equal to. So here is the symbol for the null hypothesis and the alternative hypothesis. So it states here, the null hypothesis states that there is no significant difference between the two population means. And then the second one, the alternative hypothesis, states that there is a significant difference between the two population means. In other words, there is a significant difference in the population mean scores of students who were subjected to different methods of teaching. For step 2, we calculate the degrees of freedom. In this particular part, we add the two sample sizes and then subtract by 2. So in this case, the degrees of freedom is 5 plus 5 minus 2 is equal to 8. In step 3, we determine the critical t value. To do this, we proceed at the detailed t table. So we zoom into this particular table, and the first thing that we will do is to locate the degrees of freedom in the first column. So a while ago, we have calculated that it is equal to 8. So this is the degrees of freedom. And then, okay, since we are conducting a two-tailed test, we will locate the location of our significance level alpha, which is equal to 0.05. So the intersection of 0.05 and 8 in the table will be our critical t value, which in this case is 2.306. That is why, if we go back to the solution, we have here our critical t value equal to 2.306. For step 4, we formulate the decision rule. Since this is a two-tailed test, we have two critical values. negative 2.306, and positive 2.306. A t-statistic with a value lower than negative 2.306 and a value higher than positive 2.306 are considered significant. As such, we use the absolute value notation to make the decision rule brief and concise. As a result, whenever the absolute value of the t-statistic is greater than the critical t-value of 2.306, we reject the null hypothesis. Otherwise, we fail to reject it. Now for step 5, we calculate the test statistic using the given formula. And by substituting the values that we have calculated earlier, we have the following result. The t-statistic is equal to 0.4159. Now in step 6, we formulate the conclusion based on our decision rule. As you may have noticed, our t-statistic of 0.4159 is less than the critical t-value of 2.306. That is why the result of the test is not significant. We also included an optional part here where we conducted a p-value approach to test the significance of our result. So if the p-value is less than the significance level alpha, we reject the null hypothesis. Otherwise, we fail to reject it. In this case, since p is greater than the significance level alpha, we fail to reject the null hypothesis. Again, take note that this result is always the same as with the critical value approach that we have conducted in step 6. Another optional step, we can also determine whether the mean difference is significant or not using confidence intervals. The idea is that if 0 is found within the interval, then the mean difference is not statistically significant. As a result, since 0 is found within the 90% confidence interval, and then on the 95% confidence interval, and then on the 99% confidence interval, we conclude that the mean difference is not statistically significant. There's not enough evidence to claim that there is a real, meaningful difference between the scores of students who were subjected to two different methods of teaching. So lastly, for the effect size, we use the following formula and find that the observed difference between the groups is medium or moderate, since its value is between 0.2 and 0.5. This means that the difference between the two teaching methods, while not huge, is still substantial enough to be considered of moderate significance. And that concludes the solution to this question. If you find this video helpful, please leave it a thumbs up, subscribe to this channel if you are not yet subscribed, and ring the notification bell so that you will be updated on our latest uploads. And as always, I'll see you on the next one.